Hello to my year 6, welcome to a video. Last week all about carbon, and this week all about another grundämne, iron. Eller järn på svenska. Iron undoubtedly is one of Sweden's most important materials. Iron has been mined here for centuries, and Kiruna is of course a town built upon its mining industry. Kiruna mine is the largest iron mine in the world. This makes a lot of money and is very important for the Swedish industry. Now, iron, of course, as I hinted there, to take iron, it's also found in rocks. Therefore, we have to create mines, gruvar. We need to mine to get out the iron. We need to take it out of the ground. Another invention, famous in Sweden, dynamite, is of course something used a lot to try and break apart the rock quickly so it can be easily moved. We are lucky that there are two main types of rocks in the world. Look down here. Two main types of rocks in the world that contain iron. One of them is called hematite. And the other is called magnetite. Now, in Sweden, makes it a lot easier this. Magnetite, that one there, is most common. And have a guess what one property of magnetite is. It's magnetic. You get it right. This thing here is magnetic. It is a magnetic rock which contains iron. So, what I can do is actually quite simple. If I have lots and lots of rocks, here are my rocks, that I have from my mine, I can put them in small pieces and then they can whiz around on something like this. Basically, this here is a big electromagnet. And what I can do is I can have two different buckets. And when all these rocks come down here, they go through here. If they're not magnetic, they go here. But if they're magnetic, they can go a bit further. And those rocks drop off into different boxes. If they are magnetic rocks, they are going to contain almost certainly magnetite. And they're therefore going to contain lots and lots of iron. So magnets are vital to this process. However, magnetite is not 100% iron. It is actually iron oxide. Iron does something very easily. It rusts. So because iron rusts, it reacts with oxygen. Hematite is a very, very orange colour. That's the reaction between iron and oxygen. If I want to get my iron, I need to make sure I stop my oxygen binding to it. And I tell you what, oxygen isn't that easy to move. Most things won't move it, but there's one really attractive atom that will move oxygen away from its long relationship with iron. It's not good for us, but we have to do it. We have to give it carbon. And if we give it carbon, the carbon takes the place of the iron. And of course, carbon and oxygen make carbon dioxide, CO2. We know that baby. We know what that baby does. Carbon dioxide, of course, With those two taken away, we're left with the iron. The iron as we want it. It's not that simple, sorry. I can't just put a lump of carbon on and watch my iron suddenly be transformed as this gas erupts from it. I have to use something called a blast furnace. And if you're not sure what that means, it's even simpler in Swedish. Masugn. It's a huge, really hot oven. And what I can do is I actually put in some materials into that. So it looks a little like this here. And I have 3 things that come in and 1 that goes out. Of course, going in, we see, yeah, we can see good. In I have, of course, the carbon. And of course I have the iron oxide, the magnetite. Magnetite. The third one I'll come to later on. And they go into this blast furnace. And it is very hot. We are talking many thousands of degrees Celsius. And hopefully what happens is that the CO2, well, I need to get air coming in, so it gets some air in, because then some more air will be coming out of this. And it's a CO2, it's a carbon dioxide that comes out. We have it like this here. And then at the very bottom, coming out, we get our iron. And it is molten. It is a liquid. It is so hot. One more thing comes out, because there's not just iron in these rocks. Rocks are not perfect. They have impurities. They have things that are just not right. So we actually add in as well limestone, kalksten, and then we have what comes out here, which we call some slag. Slag på svenska. And basically that there is the waste. This is the waste that we don't want, the bits of rock and so forth. The limestone helps to make a layer of that. That goes out here, and all the iron comes down the bottom. So it helps us so we get the pure iron at the very, very end. And then of course with that iron, we can use it for so many different things. It's a great building material, but of course we need to protect it as well, because iron does rust very easy. And there are 2 real different ways we can do that. We can galvanise iron. That is so that we protect with a different metal. It's very common to use zinc for this purpose. Zinc will not react with oxygen. So if I have iron to build something, and then I put zinc on the outside, it will protect the strong iron structure underneath. Or I can make an alloy. An alloy is not quite a mixture, and it's not quite a compound. It's basically the metals interlocking as a mixture kind of structure. So you get usually iron and nickel. It's a very, very common alloy, which then makes it very, very strong as well. You can also have it with iron and chromium. And these are different types then of stainless steel, because the nickel in them stops the iron bits from therefore rusting. That iron is really useful and needs to be protected. But also it's a big challenge to get that iron out of the ground. Thank you very much. Take care.